Okay, and now an example that's not in the book. They do have a similar example. How to deal with converting to vertex form from standard form when the value of a in the equation is not equal to 1. It's a little bit more of a challenge, but we can do this. The algebra method, the completing the square method, just has one extra step at the beginning and one extra step at the end. Here we go. Y equals 3x squared minus 24x plus 9 in standard form. Remember, our target is vertex form. Y minus k equals a times x minus h squared. So, like before, the first step is moving that 9 over to the other side. So I'm going to have y minus 9 equals 3x squared minus 24x. The trick now is I have 3x squared, and I really would prefer not to have 3x squared. That's hard to complete the square. Y minus 9, I'm going to factor out that 3. 3 times the quantity x squared minus 24x. There we go. That is incorrect. 3 times the quantity x squared minus 8x, because you factored the 3 out of there. 3 times the quantity x squared minus 8x, and now the question becomes what to add here to make a perfect square. Minus 8, half of that is negative 4. When I square that, I'm going to have plus 16. What you have to be careful of, I did not add 16 to the right-hand side. What I really added is 3 times 16, or 48. So now we have on the left-hand side y minus 9 plus 48 is y plus 39 equals 3. And if we rewrite this as a perfect square, 3 times the quantity of x minus 4 squared. So that is in vertex form. You notice it behaves the same as this. Y minus k is a times x minus h squared, and it's telling us the vertex is 4 and negative 39. That looks pretty good. You remember the steps were the same as before. First, subtract the number from the other side, then complete the square, but the extra step was factoring out the a at the beginning and remembering when you complete the square that you've really added something a little bit more complicated the next time. There's the completing the square version of it. Let's do the same question graphically. Again, to the calculator. We have x squared, 3x squared minus 24x plus 9. We look at the graph. The graph looks like it goes well below the x-axis again, so I'm going to change the window, green window, and go down significantly. I'm going to go to, say, negative 50, because it looks like it's quite a ways down. And if I'm going to go from negative 50 to 10, I think I will count by tens, just to have a nice picture. Here comes the parabola, I hope. Yes, that looks much better, much more helpful. So take a look here at this equation. We again have a minimum. So that's choice 3, a minimum, the lower bound to the left of the minimum, the upper bound to the right. And it tells us the minimum is 4 and negative 39. The same answer we got the other method. The same answer we got by completing the square. So, two methods here, either using a graph or using completing the square. Both give us a vertex at 4 and negative 39. Good work once more, and we're done with that.